Now I'm recording. So I'm gonna go back a little bit because you guys you are now 3, ne? You are no longer 2. So let me start. Try to send that. Okay, yeah, it's sent. It's fine. Okay, this is new. Verify the roles theorem. All right. And I'm happy that you sent this, but we were supposed to send this long time ago, but it's fine. We should have sent this long time ago. So let's start with invest, ne? Invest trig functions. So I'm sure you are all in the group. So those questions, let me try solving them for you so that you can actually. No, let me start with the ones for partial. I've got partial as well. So let's start with partial, and then after partial we'll move to that one, partial integration. Number 1, you are having the integral of x plus 14 over x squared plus 7x plus 10 dx. Okay. So with this one, we know that this can be, we can try factorizing this one out, right? That's the first thing that we will try doing. So we are having x plus 14 all over. Then this, if I factorize it, I will have x plus 2, x plus 5. Position this. X plus 5 dx. And then now I can say, I can change this fraction. Remember, this one is it's a what? It's a rational fraction. So we must change it to a partial fraction. So now I'm gonna take that part. I'm gonna take this for this rational fraction and change it. So hopefully they've already taught you how to change. So but this one's they are linear factors. So this one you should already know that it will be a over x plus 2 plus b over x plus 5. Then I will multiply both sides by this guy. This. I'll multiply both sides by the denominator, which is x plus 2, x plus 5, x plus 5, and also multiply it this side. X plus 5. So now this one will cancel with that one. We'll be left with x plus 14 equal to. Then when you multiply this here, you're gonna get a x plus 5 plus b. This and that will cancel. Sorry, this one x plus 5 will cancel with x plus 5. We'll be left with only x plus 2. Then we'll solve for a and b. So when you get to this point, there is no need for me to multiply. You can let x be equal to. Let me also try checking the calculator as well, guys, because we're gonna need it. So, guys, you must make sure you also have a calculator when you go to write your test. For some of you, you like using your brain. So -5. So On the left, if I'm letting my x to be -5, I'm gonna have 9. Then this part will become 0. Then we'll put -5 plus 2. Then this will be 0 plus b to exponent -7, 9. Okay. So from here, we're gonna have what? We're gonna have 9. We're gonna have 9 equal to -7b. Then I divide both sides by what? No, why isn't so? This is not -7. It will give us -5 plus 2 will give us -3. I don't know why you guys didn't see that. -3b. So our b is going to be -3. Then now I can let my x be -2. I hope you guys will understand why now I'm choosing 2, -2, so that this part can become 0, and then I'll be able to solve for a. So now I'm gonna have let what? Let your x be equal to -2. So now let me put this. Okay, I'm saying that my x be -2. So what we're going to have on the left, we'll have 12. Then we'll have -2 plus 5 plus b. Okay, plus b into 0, right? Guys, if you don't understand, you must stop me. Then -2 plus 5. Then 3a. Then here we have 12a. Therefore, a will be equal to 4. So our b is -3, our a is 4. And then now you come back and you substitute here on this guy. So let me do the substitution now. So I know that x plus 4 plus 14 over x plus 2 x plus 5 will be equivalent to a over, okay, we're having this first, right? B over x plus 5. My a is 4, x plus 2 plus my b is equal to, we got -3, x plus 5. X plus, oh wait, let me use the small one, x plus 5. So now you can integrate this part, the partial fraction. So this one, it will be your partial fraction. So now we must integrate it. Now I know I can integrate the what? The partial fraction, which will be the integral of 4 over x plus 2 minus 3 over x plus 5. Isn't it? Is correct. And then the x, and this will be equivalent to, then you can distribute the integral sign. So this will be 4, the integral, when I take out the constant. So this step is not actually necessary. I just want you guys to understand, but you can also write it when you are writing. Actually, it is necessary. Yeah, just to show your lecture that you understand that you must take out the common factor. So remember, when the degree is 1, you'll just put ln minus 3, the ln x plus 5 plus 6. Did you guys understand? So this will be our answer. Do you guys understand how we did this one for linear factors? Remember, this is a linear, né? So when you separate a linear, you separate it in this way. Did you understand, guys? Can you confirm?
Yeah.
Then go to now. Okay, now go to number 2. Negative 2x plus 4. This is what you are given. Okay. Having 2x, okay, minus 1 minus 1 x squared plus 1 dx. Yeah, so now you are given, right? Is what we are having. So in order to separate, you are going to have negative 2x plus 4. So the first one is a linear factor. So this one is a linear factor. We can all see that it's a linear. Then this one is an irreducible because you cannot factorize it. By irreducible, we mean something cannot be factorized. Irreducible. So now this will be a over, for the first one, which is a linear factor, we will do that, right? So to separate for an irreducible polynomial, which is a quadratic factor, you'll have now we'll go to the next step, which is b x plus c, x squared plus 1. That's how you must separate. So make sure you know how to separate. Then now we'll have what? I will multiply both sides by this one. Minus 1 x squared plus 1. And guys, I'm expecting distinctions. Ne? Cannot fail test 5, guys. You can't afford to fail test 5. Must make sure you get high marks. So that when now you write the exam, you are not scared, right? So some of you already you are missing upon simple test. So test 5 is the same as test 4, just that now they are adding new content, right? If you understand differentiation, you must also understand this thing. This x minus 1 here. And then now we know that this one will cancel out with this one, right? And then what else? 4, and then I'll be left with, let me write, we'll be left with negative 2x plus 4. Then this one will cancel out with this one. You will be left with a of x squared plus 1. Then when we come to this one, you will be left with plus bx plus c. Then this one will cancel with this one, so we'll be left with x minus 1. Hope you all understand up to date. So now I'm gonna let my x be equal to negative 1. Then I know I will have this. This will be 0, 1 plus c. Then this one, if it's negative 1, it means I'll have negative 2. Now, we'll be left with negative b plus c, right, into negative 2. Set x to be, okay, let me check something here. No, we're supposed to let x be 1, not negative 1. If we let x be 1, this part will become 0. So with whatever I'm writing here, we'll get the answer. So let our x be 1. So meaning that here we'll have this. And then 2 plus 0. I don't know if you can see, this part will become 0, right? Mm, yeah. So now you will be left with 2a. Then negative 2 plus 4 is just 2. Then our a is equal to 1. So a is equal to 1. Fine. Then now we can let, if I let my a be this one, let me see, if we let our x be equal to 0, we'll actually be able to calculate the value of one of them, right? Yeah, let me copy this. Let's let our x be equal to 0 now. Now I'm going to let my x be equal to 0. Let me use a different tab. X be equal to 0. Now this will be 4 on the left, you have 4. Then and then what? And then you put 0 with the x, you'll have 1. Okay. And we already know what's the value of a, right? It's 1. So we can also substitute it. It's 1. And then you come here, the value of b we don't know. Then while letting x to be 0, then here we'll have negative 1 into negative 1, 4. Then you'll take this one to the left. Then you'll have c being equal to negative 3. C will be equal to negative 3. Yeah, is this correct? Let me check. 3. Yeah, you'll get your c to be equal to negative 3. Let me see what we're having up here. So now we must try to get the value of what? Of b, right? So we already have two variables, so I think this will be easy. Let me try to get the value of b. So let me copy this. Okay. So the next page. Now we already have the value of a, which was equal to 1. Yeah, it's equal to 1. Then meaning here you just have x squared plus 1 plus the value of b, we don't know. No, yeah, we don't know. And then the value of c is negative 3 x minus 1. So you see now we're only having one variable. So here you can choose x to be anything. Ne? Let's say we choose let x be equal to 2. So I can substitute that 2. Then here I'll have 4 squared. I'll have 4 plus 1 is 5 plus b into 2 minus 3, 2 minus 1. So yeah, it won't affect anything. Any value you choose, right? It's not going to affect the value of b. So let me see. Here we'll have 2b minus 3 multiplied by 1. This side will be 0, right? Then you'll have negative 5, 2b minus 3. Yeah, and then you take the negative 3 to the right, you'll have what? Negative 2, 2b. B will be equal to negative 1. So I'm saying that any value that you're gonna choose for the last variable, you will choose any value. Just choose small values. For the third value, it's okay to choose any value. You'll get the correct value. So we have all the values. So we can come back and substitute. And you're allowed to ask, guys. Don't forget. Don't forget to ask. Let me go down. Now we're here. So now what we're going to have now, we're going to have our value of A. We got 1. So this will be 1 over x minus 1. Then the value of B is negative 1. So we'll have negative x. Then C was negative 3. So you'll have minus 3 over x squared plus 1. So now we can actually integrate that. Then actually integrate this part. So now I'm going to have the integral of 1 over x minus 1 dx plus what? So we don't have to separate them. Let's first write it like that. Negative x minus 3 x squared plus 1 dx. The integral negative x minus 3 x squared plus 1 dx. Then this will be equivalent to okay, I think this one might need us to also use partial again, this part. But we'll try to use this substitution. No, I don't think it will work. Let me see. Never. No. Okay, yeah, we'll see how we do this one. Okay, here we'll have this part. So I think you guys, you can allow me to say for this one, I will have the integral of negative x squared plus 1. Let me first separate this so it can make things easy. X squared plus 1 minus 3 x squared plus 1 dx. So now for this one we already know the answer, but so now let me not write it. So I'm having this minus the integral of what? The integral of 3 over x squared plus 1 dx. Okay, so okay, this one just gonna move you. So now this one we know the answer is ln of x minus 1. That's the answer. Plus, then for this one, let's use substitution. So I think you should actually, because you'll be writing, you'll say from. For the ones that you don't know the answers yet, you solve them separate. So here I'm gonna say let u be equal to x squared plus 1. So here I'm applying this substitution, then I'll get 2x. I knew that if I differentiate that one, I'll get an x. So now the x will be equivalent to the u over 2x. Then I can come and say I'm having negative x over u times the u over 2x. Then these two, they will cancel each other. I'll be left with negative the integral 1 over u of 2u, the u. So the answer here will be negative 1 over 2, the ln of u plus c. Are you guys still fine? You still understand? And this will be equal to negative 1 over 2, the ln. Then you substitute back your u, which is just x squared plus 1 plus c. So you know the second answer is this one. Then you go to the last one. Then you say from the integral 3 over x squared plus 1 dx. This is the third one. So this one, if I take out the constant, I will be left with this. So the integral of this, I think you have done inverse. So this falls under inverse trigonometric what function? The integral of inverse trigonometric functions. So the answer to this one is just the arctan. The arctan of what? Of x plus c. Yes, remember once you are having the integral of a constant over a squared, let me say a squared plus the other one is u. They usually use u squared from these rules. Now this one, let me see how they actually write it. Let me check this rule just to remind you. Let me just remind you of these rules. Now, how can I write this? Let me write here. Remember that when you are having these guys, the the integral of the u over a squared plus u squared. This will be 1 over a, then the arctan, of what? Of u over a. Then the second one, this one will be the first one. The second one, when you have the integral of the u over the root of a squared minus a squared, this is equal to the arctan of u over a plus c. The integral of the u root of u squared minus a squared will be 1 over a, the arcsec. So I'm just reminding you of these rules. The arcsec of u over a plus c. On the guy, I already sent these rules on the group as a picture, right? So some of you, okay, the person that just joined, they might not have it, so I'll try to send. So now, as we're having what? Our a, what is the value of our a? We're having this identity, this one, this property. We're having 1, right? And then the x over x squared, meaning our a is 1 plus x squared. So I knew that, okay, since this one can be written as 1 squared, know that this can be 1 squared. So I will have 1 over 1, the arctan of x over a, which is 1, which will be the arctan of x. Just showing you how that property works. Similarly, when you were having, let's say you were having what? 4 dx over 2 plus x squared. So for this one, you're going to take out 4 and you will have what? Dx 2 plus x squared. You know that this one can be written as what? The square root of 2 squared plus x squared. Meaning that this was going to be equal to 4 1 over root 2, the arctan of x over root 2 plus c. So you see that knowing these rules is very important, but it's fine. I was just showing you how you actually use them. So now let me move and substitute back my things. So I'll have to copy this part. Guys, I will still fine. I have a lot to do. And this will be the ln x minus 1. So the answer of the second one is this one up there. I'll just copy them. It's already found them. This one is negative. And the last one is 3 arctan x. 3 arctan x plus c. So our final answer will just be like this. Plus c. Guys, are you still fine? Hey, I think maybe I should stop here and ask if you are still fine. You're all fine?
Yeah.
Oh, sharp. Now I'm moving to, let me see what else we can see then. Now I'm moving to the integral of what? Of inverse trig function. Of inverse trig functions. So one of those questions we've done it already. So, but I'll just repeat it. I'll try to be fast, guys, because we have a lot to write here. So this one, it should not trick you, guys. So this one is very easy. The x. You know that this thing can be written as what? Let me see. You can write this as 1 plus 2x, and then you square this. This one is a little bit tricky. So from here, we can try doing what? Yeah, if I can write it like this, I can use u substitution. Let u equal to 2x. Then the u over the x will be equivalent to 2, which will imply that the x is equal to the u over 2. You see, so this will be the integral of 1 over 1 plus u squared, which is what I want. Then 2. Then the answer to this, it will be arctan of u. Remember, when you apply that condition, it will be like this, right? X over 1. This is 1 over 2 plus c. Then this will be 1 over 2, the arctan of x plus c. This you don't have to write. I'm just showing you. Remember, I'm teaching you to understand. Then this will be equal to 1 over 2. This will be u, not x. Then this will be the arctan of the value of u. We say this, it's 2x. So you'll substitute it back plus c. So that is actually equal to this. So that's the first answer. Go to this one. Change this. Number 2, you go to the dx, the root of 3. This one is whereby you have to complete a square. I've already taught you. But I think we also did the correction of this one. This one will be negative x squared plus 2x plus 3. And guys, okay, with that homework that I gave you, we're not gonna do it. You'll have to do it because when I give you, you don't write. Yeah. So you must actually work. Then this will be negative x squared plus 2x minus 3. If I'm taking out the negative out, then now I must complete a square of this. Remember to complete a square.
2x negative.
2x will be negative, okay. Thank you. So now, yeah, a lot is going on. So now we are having what I was saying. If you are having x squared plus bx plus c, this will be, if you're completing a square, it will be like this. minus, and then you subtract it, b over 2 squared plus c. It will be like that always. Okay. So now we are going to have what we left the integral of the x all over the root of negative x squared minus 2x. This will be negative 2 divided by 2 all squared will be plus 1 minus 1 minus 3. Then you will have the integral of the x. Then you're going to have this, the, the integral, the x root negative. This will be x. This part we can actually just say it's x minus 1 all squared. So the negative 1, where am I getting it? Let me show you. Remember, we're having this now. Then I apply the what? Negative 2 divided by 2 will be negative 1 all squared minus negative 1 all squared minus 3. So I'm taking that negative 1 and then I'm using it as our factor. So you must know how to complete the square. If you didn't know, make sure you know, because there is no you'll write Test5 without completing a square. Ne? They wanna see if you still know your things. So this negative was outside. So make sure you just put square brackets ne? to avoid making mistakes. Yeah, put the square brackets so that when you do your things like that. I used to have a problem when you don't put the square brackets, there's no way you'll make a mistake. So from here, what can we do, guys? I've completed the square. Integrating this one. By having x minus 1 squared, this can be, that 4 can be written as 2 squared. Okay, we have that negative, so we must distribute it, right? So we'll have positive 4. I think you can all see this. Here I'm just simplifying this negative out. Hence I was saying it's important to make sure the negative is outside. So now I will have that and then squared. And from here, we're gonna say, from here you can also try using U substitution. I think it can help. You let this one be U, isn't it? Let's use U substitution from here and see what we'll get. Let U be equal to x minus 1. The U over the x will be equal to 1, which will imply that the x is equivalent to the U. Then I can put the U there. And then here I know I'll have 4 minus U squared. So this thing is simplified thing. Using U substitution can actually help you. Ne? Yeah. So this one we know is that one for x side. We know that this can be written as 2 squared minus U squared. And remember, I said if you have the integral of the, okay, let me use, they were using U there, the U over a squared minus U squared. Then you have the root there. A squared. We say this will be equivalent to what? To 1 over a, ne? The arc sine of u over a plus c. So now you should not be surprised when I say the answer will be 1 over 2. The arc sine of u over a is 2 plus c. Then what was the value of u? You replace it back. It will be x minus 1. 1 over 2, the arc sine, x minus 1 over 2 plus c. But you could have written it straightforward from here without using the substitution, right? So that's another way of actually doing it. Or if you actually know your stuff, you will just come here. You know that this one will be equivalent to, you know that this is root of 2 squared minus x minus 1 squared. So you'll just apply that rule. So you know that this one just going to be 1 over 2, the arc sign. This one is your a, it's your u, sorry. So it will be x minus 1 over 2 plus c. So you can actually just write this answer without going to use substitution. So I don't know which one is best for you. So now let me move to the other parts. Now I'm going to, let me move to the arc length, but the arc length you already know it. Okay, let me move to now the length of the curves. Ne? So I want us to do everything guys today. Length of curves. Don't know. Are you guys tired or you still have energy? So I having y equal to, it finds the length of ln of cosine x on the interval 0 and pi over 4. So I said the formula will be like this. You guys know this formula? I think by now you should know it. I told you last time, so you should know it. I don't know if the other one know that formula. So okay, fine. Let me continue. So guys, now we must find the length. Ne? So what we're going to do, we must find the integral first. That's the first thing. And then after it's area. Around, bring your phone first. Open it. Oh, understand this. Guys, you are still fine. Eh?
Yeah.
You are still good. All right. Yeah. Cool. Okay, so let's continue. So now I'll find the derivative of this one. You'll say, for this one. So this is our f of x. So on the questions that you sent on the group, they wrote y. So I'm gonna put f of x ne, just so that you can all full, so that it can make sense. So we'll find the derivative of that. So it will be what? It will be negative. The derivative of this guy is negative sine x over cosine x. That you know. And this is equal to negative tan x. Then identity, right? Now you just substitute. Then you'll have L. Yeah, our intervals is pi over 4. This one is the biggest one. So the biggest one is the upper limit. And this one is the lower limit. Negative tan x. Then you substitute your derivative squared. Then our dx is equivalent to what? Okay, we are not doing substitution. So this will be L pi over 4 0 1 plus tan squared x dx. Then what are we gonna have now from here? We'll just say L is equivalent to, this one is an identity. So we'll just replace that identity. squared x dx. So this will be pi over 4, 0, sec x dx L. So this is what you are having. So the integral of arc sec u of sec x is ln sec x plus tan x. So remember this, then pi over 4, because I know you forgot. In the test, then you are going to forget, some of you. Ne? To remember what is the arc sign of this, remember also have what? Sine x, cosine x. We've got this 3, ne? So in order to, you see, the last one is wrong. The last one should be what? Cosec x, sec x. So it's cot x. So to remember the integral, you must remember the derivative. So let me do this. Remember the derivative of sec x on differentiation, it was equal to 1, 2. It was equal to sec x tan x. So the integral of sec x, you will just put positive here, since this is starting with s. So you'll just put positive in between, ne? Plus c. It will be the ln, sorry, plus c. Then to remember the one for, that's why I said you must remember that abbreviation that I once gave you. You'll always use it, even on test 4 you use it, even here. Here's cosec x. For cosec x, the answer was what? We move 1, 2. It will be negative cosec x cot x. So the answer will be the ln of cosec x minus cot x plus c. The integral. Guys, I hope you are following this. Ne? Then the last one, cosec 1, 2. The last one is cot. So what was the integral? What was the derivative of cot x, guys? I wanna see if you were to get. What was the derivative? What's the derivative? Or I should skip, ne? I don't have to explain because you're not responding. What's the derivative, guys? You? Yes, where is Shasha? I thought you guys you are 3 here. Are you guys 3? 1, 2.
You two.
You are just 2. I think I saw someone join me, but I think,
Mean.
oh, she went out. Okay. This one. No wonder why this class is quiet. In case you are not talking today. When you are 2, you talk. So now this one, it's negative cosec x squared. So, squared, you know? 1, 2, yeah. You move 1, 2. And then you take this one, you square it, and then you put the negative in front. So the integral of this one is what? I think I forgot this one. What's the integral of cot x? The integral of cot x dx. What is it? Will it be the ln of cosec x? Which will be ln of 1 over sine x. Yeah, I think it's this one. You'll just confirm, né? But yeah, it's supposed to be that one. So I'll just reminding you. Now, from here, you substitute your intervals. Guys, if you have a question, ask. Don't be afraid to record. Then now we're here because now this is your last test. You must make sure you perform. I want good marks. Then with this one, we're gonna have what? You'll have L. Remember, we're looking for our L. We'll substitute before we substitute, we'll change this like x to be like this because we cannot substitute on sec x. It's not there on your calculator. Plus tan x I over 4. I hope you understand why we're having two of these. That one is for the interval. To take care of this interval, it should be longer. This one should be short. So you'll have ln of 1 over cosine pi over 4 plus tan pi over 4. Ne? That's what you will have. Then let me reduce this. Then you will have minus, you substitute also on this one. And then I will know that if you put 0 on cos, you'll have 1. So let's just have 1 plus tan of 0, which will just be 0. So here we'll be left with ln of 1. Ln of 1 is what? Is 0. So this is 0 minus. So you put that on your calculator. Né? Make sure your calculator is in what? In degrees. It should be in degrees. Or they said it should be in radians, guys. I think it should be in degrees. No? Hey, let me change it to radians. I think I'm getting things here. Okay, let me first check again. Tan of pi over 4. Let me change it to radians and see what I'm getting. Pi over 4. Nah, still the same thing. I was expecting maybe I'll get a fraction. Eh? So yeah, keep your calculators in degrees. And unless if they told you in class that it must be in what, then you can change. Pi over 4. So I'm getting 0, 0,0137. So since I'm talking about the length of the curve, you can just say meters. Ne? Yo, guys, the second one you will do it. Ne? I should skip this one. Will you do it or it's difficult? You'll do it. Ne? I don't know. So I want us to do those other ones. The interval is 1 and 4. You'll just differentiate this one. Let me put f of x as well here. So we're done with the length. Did you guys understand? Yes, did you understand? This is 0,07.
Yeah.
Okay, this one you will do it. If you struggle, you'll tell me. Now let me move to Rolle's theorem. No, we have to do the area. And these things are very easy, guys. Very easy. You can get total, you'll see. Just practice that one for let me see which one is difficult. I don't even know which one is difficult because I think all of them they are the same weight. So now the area of curves. This thing is not okay. By here, area of curves. number 1, you are having, I will also use f of x for this one. You are having x plus 6, and then they say error of curve. Okay, they give us 2. These 2 functions. Yeah, I will have to check this one quick. And y equal to x squared. This one doesn't have intervals. Okay. Let me check this one out. So you're having 2 functions. You must find the area between. Oh, I get it. Yeah, and this one can come. Ne? Actually, yeah, those questions you send yes, ne, that the scope. So yeah, this is the scope. So whatever I'm doing will be there on your chest, everything. So, everything. So make sure you cram if you can cram. If you can't cram, I don't know. So now let me do this. So in order for you to know the area between these 2 functions, so this is what is happening. Ne? You are having a parabola because this is x squared. It's like you are having something like this. I'm just giving you an illustration of whatever is happening. So this one, it will be a straight line, it will be like this. So we're calculating the area. You get it? So in order for us to get the area, we must actually know what is it between? So it is between what and what? So this will be our A, this will be our B. X, B. Yo, let's say now I'm writing A. This is the y axis, that's the y x axis. Nice. My pen is misbehaving. Yes, not nice. But this will be x squared. So I'll just equate the 2 graphs. That's what you are supposed to do. In order to get the what? The intersection. This is what you will always do. And then with the one whereby you are given an interval. Let me also write it here. When you are given an interval, I'll go back to that one. You'll use this formula. It's there on your guide. You'll use this formula. It says area. They wrote S on your guide. Let me use A to represent surface. Okay, let me say SA. Surface area is 2 pi the integral of BA of the function that will be given the root of 1 plus the derivative of that function. So I don't know which question will come the x, but this one they won't bring it. I don't think they can bring it because you might not even remember this formula. Ne? But you should, because this you are just introducing what 2 pi and the function on that one for length. The only part you are changing it's here and here. So I think you should also know it, but it's fine. So with this one, you will just find the intersection. So you are going to equate x squared with x plus 6, and then you calculate the intersection. So I factorize this minus 3 and plus 2. Then x is equal to 3 and x is equal to, you see I'm saying and, you must also write n. X is equal to 2. So meaning this could be 3, this could be 2. No, why is, hey, we're supposed to get, the other one is negative 2, ne? Not negative 2. And it makes sense. Remember that a parabola, for this thing, it will be like this actually. For this scenario, you're going to have your negative 2 will be here, then here you left your 3. Then plus 6 is somewhere there. So it's actually like that. So it's this area that we are looking for. Now let's calculate. So after knowing the intersection, what you must know, you must know which one you're going to start with. So you're going to do this. So for the area, between, so okay, now I see. So this is the area between two functions. Let me say two functions. Yeah? So whereby you will have to use this formula. This one is the area of what? I don't know in your guide what they wrote there. Surface area of a curve. Usually they will give you the interval. They will give you the interval A and B. You'll only have to substitute and get what your surface area is in meters squared, obviously. But I don't think they'll penalize you if you don't write meters squared. It's not really necessary. So now let's do the area. So we're going to have what? We're going to say area is equal to the integral BA. Then the first function. Let's name them differently. No? So the one which is above. Okay, so you must know how to check which one will be above. Because usually it gets tricky. But with this one, I think it's obvious which one will be above. Oh, this thing cannot detect. Okay. So let's determine which one is above, né? So that we can know what are actually subtracting here. Generally, it will be like this. The upper, the low. Let me add the page. Then in order for you to know which one is above, you'll just pick. Let me see how they do it. Test value. You'll pick a test value, né? Yeah. So the test value must lie between these two intervals, between 3 and negative 2. You choose a test value. So say choose a test value. Then let's say you decide to say, so any value between negative 2 and 3. Let's say you choose, let your x be equal to 0, because these test values, they lie on the x-axis. Hey, what's happening? Okay, let me take this to the next page. So let's say you decide to let your x be 0. So our equations, it was this one. So let's name that the first one for x squared to be f, the second one to be g. So if you substitute 0, this one will be what? 0 squared. It will just be 0, right? You'll get your answer as 0. But let me show it. It will be 0. This one, your answer will be 6. So this the bigger value, so g of x is greater than f of x. So the bigger value shows that this one will be the graph that is on top. So the linear graph function, you know that it will be the one found above. So when you subtract, it means it will be a. Okay, let me use different color. It means it will be g is the linear minus the second one, which is the quadratic. Then you will have what? Our b is 3, negative 2. This is x plus 6. This is x squared dx. So I taught you how to do this. Ne? So don't make a mistake. So this will be, so let's simplify this part. It will give us what? We will have x negative x squared you negative x squared plus x plus 6 plus, and then dx. This will be 3 negative 2. Okay, now you'll have to integrate everything there. So if you integrate, you're going to get what? Negative x cubed over 3 plus x squared over 2 plus 6x. I hope you know how to integrate. And then you put your limits there. Then that's it. Let me add the page. So now you'll have what? You'll have to substitute the first point here, then you subtract the second one. So you'll do this. So I'll just show all the steps. Minus, then you put the second point over 3 negative 2. So the answer for this part will be what? You should get 27 over 2 for this one. Let me check. Let me be sure, because I was just substituting 3. Yeah, you'll get 27 over 2. For the next one, minus, you'll get negative 22 over 3. Then the final answer will be 125 over 6 meters squared. Did you guys get it? And this will be our area. Now let's move to, what was the next question? Let me see. Let me check what was the next question on your slide. You were on your what? Okay, you were even what? Find the area between. Okay, now this one will be your exercise to do. You will go and find the area. So we'll be sending this in the group of the two curves, when you are having what? So I'll name the first one to be, the first one is x. I'm naming it to be f of x, and the second function will be g of x. So go and find the area. The points you'll first, so the first step will be to find the points of intersection. So let me find them for you, so that you just continue from here. So I think you'll get x to be plus or minus the root of 5, and x is equal to negative root 5. So this is where the intersection happens. So go and get the area. Now we do Rolle's theorem. Is it fine? So let me start. I like the mean value, but okay, let's start with the Rolle's theorem. Rolle's theorem. This one they never taught us, but this is what you did on first semester. Just that they want you to verify. You see, to verify what you already know. So let me see how you verify. So you were given f of x equal to x squared minus 2x minus 8. Then the interval negative 1 and 3. Yes, are you still here or I'm alone? Yes, and Vanessa, you guys still here? Hey, Evan. Guys, are you still here? That one left. Hey, let's see something here. Okay, let me just continue. Okay, you'll have to give me 2 minutes. Ne? Yeah, 2 minutes. Okay, can we continue? Okay, yes, can we continue? Okay, guys, let me just continue because I don't know if I'm still, if you guys are still here, if you guys are still here or not. So this is what you will do. The first thing to check on the group. How you guys are leaving the session. Okay, so this is what you'll do now. The first step is to first. So there are three conditions that you must check in order to verify the Rolle's theorem. The first one is for you to check if the function is continuous on that interval. Check if f of x is continuous on the interval -1 and 3. So polynomials they're always continuous, né? So since polynomials are continuous everywhere, there is no value that you'll substitute that will make your function to be undefined between these 2 points, right? So f of -1, and yeah, you can just write it like this: f of -1 and f of 3 are continuous. And you can write it like that. And you can also add and say polynomials are continuous. Polynomials are continuous everywhere at all points. Can be more specific and say the polynomial f of x is small. Yeah, let's write it like that. The polynomial f of x is continuous everywhere. Let's write it like this. Continuous at all points. You can say between -1 and 3. Okay. The second thing to check is if the function is differentiable on the interval -1 and 3. So meaning you will have to differentiate your function. So the derivative of f of x is 2x minus 2. So now f of -1, I don't know what they're getting. You will get -4. Then you also do f of 3. You'll get 4. So the function is differentiable. Differentiable at f prime 1 and f prime 3. Okay, number 3. The last condition is this one. You will have to check if f of a is equal to f of b. That's how you do Rolle's theorem, right? So meaning you'll have to check if f of, so this one is our a, this one is our b. F of -1 if it's equal to f of 3. That's what you'll have to check. So are they equal? No. We didn't check. We'll have to substitute on the original equation. So we know f of x was given by x squared minus 2x minus 8. So if you check f of -1, 8, you will get -1 squared minus 2. You get -5. Then you also check for this one. If you find that they are not equal, and then Rolle's theorem is not satisfied, so you'll also find that this one is equal to -5. So f of negative, therefore f of -1 is equal to f of 3. And then the value in the cube is that. So now the last step, I think all of these they are fine, but there is also this one I just noticed. You can say from the interval 1 and 3, you will choose any value. Anybody says like that. I will see. Okay, you'll just, on the fourth condition, you must find a value such that the derivative of our function it's equal to 0. So that value will call it c, or you can call it z. Let's call it z. So we already know that the derivative of f of x is equal to 2 it was equal to 2x minus 2, but I'm going to say 2z minus 2 equal to 0. Then if you solve for z, you'll find that z is equal to 1. So, so this value you check if it is in between the interval that were given up there, -1 and 3. You were given this, ne? So you must check if in the open interval, -1 and 3, there exists a zero, such that the derivative is equal to 0. So therefore, since f prime of 1 of z lies between, which we call, so this z, since z equal to 1 lies between the open interval, -1 and 3, then there exists a value. There exists. So the point of Rolle's theorem is to actually check if there will exist a value in your interval, a value C that satisfies, and then therefore Rolle's theorem is satisfied. So I think we've done enough. I don't know. It's satisfied. Or a Rolle's theorem holds. Any question? Should I stop the recording here, or we should continue to mean value theorem? Then we're done with everything. So on the mean value theorem, this is the question that we're having. So I'm gonna stop here because so this will be all after this one. So I'll just do one example, then that's it. So that's where we're gonna stop. So they wanted us to verify. Okay, even here they wanted us to verify the mean value theorem. The mean value theorem of this. The first question was f of x equal to x squared minus 5x plus 1 to 5 between those two intervals. So let me actually see how we tackle this one. So the conditions, there are also three, I think. Let me check. Mhm. Okay, here we also have four conditions. So the first one will be to check continuity. So they are similar to and differentiability. Then the next one, they are similar to the ones of a of Rolle's theorem, the conditions. Then the second one is you must find if f of a and f of b exist, right? Okay, you must actually calculate the slope. This is the second condition. So if the slope exists, you are still fine. B minus a. Then the third one, this is the second condition. You must actually find the value here. Then the third one will be for us to get find the derivative. Okay, we must find the derivative of our function f of x such that the derivative at a certain point, as you see, it must be equal to the slope. Let me just say the slope here first. Then meaning f prime of c must be equivalent to fa minus f of a over b minus a. Okay. Then the last thing will be to check. So this, it will enable, so after doing this, right, you will get the value of c. If the value of c exists, then you go to the fourth condition, IV, and then you verify if c is between a and b. Yeah, so you guys, you just have to follow the steps, and then you get the answers. So let me start with the first one. Number one, the first one is to check the continuity and differentiability. So f of x, since it's equal to this, it is what? It is continuous. And differentiable everywhere. Every way. So actually, let's just put it like this, to put a lot of English. Ne? So you'll see the function f of x is continuous and differentiable on 2 and 5 on that interval that they give us on the question. Remember, you were given this interval 2 and 5 differentiable. So the second part is the one where I said we must check what the slope if it exists. So we know the slope, it's going to be f of b minus f of a over what? A minus b. No, b minus a. We know that this one is a, this one is b. So the first thing will be to first get what is f of b and also what is f of a. And also what is f of a. So now let me substitute. You'll get what? You'll get -5. Then our f of b, you'll get 1. Now I will substitute on the slope. So our slope, let me use a different color. So on our slope, we're going to just have 1 minus -5. My b it's 1, my a is -5. Is it that I made a mistake? So no, my b it's 5, né? My b is 5. Remember, given this, we're given 2 and 5. My b it's 5. My a is 2. Yeah, that's what you'll have. And then you'll have 6 over 3, which is just 2. So our slope exists. And then now go to the third condition. We must verify this. Find the derivative. We must find the value of what? We must find the value of c if it exists by equating the derivative of our function with the slope. So we'll find f prime of c of x, but at a certain point. No, but let's first get f of x. F prime of x, it will be what? 2x minus 5. That will be the derivative. 2x minus 5. So now f prime of c will just be 2c minus 5. You'll just replace c with x with c. So now you'll equate 2c minus 5, the derivative, with the slope. So these two things, they are equal, ne? Hence we're actually equating. So you equate it with the slope, which we got as 2 here. So it will be 2. Then 2c will be equal to 7. C will be equal to 7 over 2. Now, we must verify if 3.5 lies on that interval. So our interval, now we must verify if C lies between what? A and B, right? A and B. So this, you can clearly tell that since the open interval is 2 and 5, you can clearly tell that C lies between 2 and 5. C lies between the interval between 2 and 5. So therefore, you can say the mean value theorem. Let's just say MVT is satisfied. And with, that with C being equal to, so getting the value of C is very important. It has got marks, ne? But this usually comes with a 5 marks. 5 marks, even for that other one, 8 marks. This will be 5 marks. Even when you're doing that other one for Rolle's theorem, 5 marks. Okay. So this way, we're going to end our session.